So there are some important features that we could pick up on from the genetic code here. The first is that some amino acids are coded by multiple codons. In the answer to the last exercise, we sort of explored this a little bit and see that alanine is coded by GCU, GCC, GCA, GCG, and this happens for some of the other amino acids as well. Another feature is that some amino acids only have one codon that codes for them. For example, tryptophan just has UGG. Another feature is that some codons have special functions. For example, we see 3 up here, UAA, UAG, and UGA code for stop codons. There's no amino acid, and it seems to signal the stop for translation. And over here, we have one codon that seems to code for an amino acid, methionine, but it's also representative of the start. It appears that there's a start codon. This AUG turns out to be really important because this start codon is necessary to start protein synthesis for translation. This is the codon that tells the ribosome where to start. Alternatively, these stop codons are essentially signals that tell the ribosome where to stop. So now, using the genetic code here, I want to see if you can find the start codon, the stop codon, and the codon that codes for alanine, or ALA, in this following mRNA sequence. There are 3 codons to choose from, AUG, GCA, and UGA. And for each of these options, start, I want you to pick one of these 3 checkboxes that corresponds with one of these codons. If you have trouble reading this genetic code right here, just look in the instructor's notes. Anytime you have to use the genetic code, and I'll always give it to you, for any question, just look in the instructor's notes and there'll be a link right there. You can also download it, keep it to yourself. You can Google image search other genetic codes if you're interested in seeing them. But go ahead and use the information here to see if you can answer this question and select the correct codon for start, stop, and alanine.